Hello viewers, and in this class I will try to establish the derivative of y is equal to cot x from first principle. So we use the first principle, to find the derivative of cot x. Okay, here cot is the inverse of tan, and we know that tan is sine x over cos x, so that our cot x become cos x over sine x. Okay, that is the inverse of tan. Cot is the inverse of tan, and we know that tan is sine over cos, so that our cot become cos x over sine x. And we know that from our first principle, y become y plus delta y, and here our cos x become x cos x plus delta x. At the denominator will become sine open bracket x plus delta x. Alright, and we know that this y we have to move this way, and we know that y is already cos over sine. This become delta y become cos open bracket x plus delta x, we'll close our bracket, divides sine open bracket x plus delta x, we'll close our bracket, minus the y, and we know that y is cos x over sine x. And observing this expression, this is a fraction already, and whose denominator sine open bracket x plus delta x sine x. Okay, and for us to obtain our LCM here, the LCM become the product of the two denominator of the fraction. Okay, here the denominator will be sine open bracket x plus delta x, then a sine x. And if sine open bracket x plus delta x sine x divide the denominator, which is this, what will be left here will just be sine x, and sine x will multiply the numerator of this fraction, and this fraction become sine x cos open bracket x plus delta x. Similarly, if sine open bracket x plus delta x close bracket sine x divide this, the denominator of this fraction, this part, it will be left with sine open bracket x plus delta x, and this will multiply cos x, so that we have here minus cos x sine open bracket x plus delta x. Okay, and what we should note here is that we have to look for an expression for cos open bracket x plus the x, as well as sine open bracket x plus delta x close brackets. So sine delta x is equal to this. So sine open bracket x plus delta x are the equivalents from the sum of angles. From the sum of angles is equal to sine x cos delta x plus cos x or sine delta x. That of cos x plus delta x become cos x cos delta x minus sine x sine delta x. Okay, so in each of these term here and here, we will replace it with this expression. Wherever we see cos x dx, we'll replace it with this. Wherever we see sin x dx, we'll replace it. But one thing should be noted is that we will not tamper with the denominator. Okay? In place of sin x plus delta x, we will not replace it with the alternate expression here. So what we'll be doing here is that we'll come here and this become delta y. This is sine x. So we know that in place of cos x plus delta x, we are replacing it with this expression. This become cos x cos delta x minus sine x sine delta x. We'll close the bracket here. Okay, and on this part we have a minus cos x. We'll close our bracket. The equivalent expression for sine x plus delta x is sine x cos delta x plus cos x sine delta x. Okay, we close our bracket here, or close our bracket, and divides what we have at the denominator, which is sine open bracket x plus delta x sine x. So let's open this bracket. We hear sine x multiplying this first part of this bracket, and here we have that our delta y become sine s cos x sine s cos x cos delta x. Similarly, sine s multiplying minus sine s or sine delta s, that will give us minus sine square x sine delta x. Okay, we come to this bracket here. Cos minus cos s times sine s cos delta s, that will give us minus sine x cos delta x. Okay, similarly this one minus cos s times plus cos x sine delta x, that will give us a minus cos square x. Okay, cos square x sine delta x divides what we have at the denominator, sine open bracket x plus delta x sine x. Okay, now let's look at this carefully. We see that this expression and this one, they are off. Sine x cos delta x minus sine s cos delta x, they are off already. So they are off, and we'll be left with delta y becomes minus sine square x sine delta x. Okay, here we have a minus cos square x or sine delta x divides sine open bracket x plus delta x or sine x. And what is common here? What is common? Minus sine delta x. So we factor it out so that delta y become minus sine delta x open bracket sine square x plus cos square x divides sine open bracket x plus delta s close bracket sine x. Here, this term here, sine square x plus cos square x is 1 from trigonometry, so that our expression, our dy, becomes minus sine delta x divide sine open bracket x plus delta x sine x. Okay, here our interest is we are looking for the y dx, so we divide both sides by the y dx. Please take note that if we are dividing both sides by the x, it will only affect the numerator here, so that our dy divide that means that y delta s will becomes minus sine delta x divide delta x all over sine open bracket x plus delta x sine x. Okay, it will affect this numerator alone. Okay, then we apply the principle of limit to both sides. We say limit as delta x tends to 0, so that our delta x, delta y will tend to the y dx. Okay, so here if we apply this limit here on the numerator as delta s tends to 0 of sine delta x over delta x of sine delta s over delta x, we look at the denominator here. When delta x is 0, this place become sine x sine times sine x. Okay, and we know from limit that as limit of delta s tends to 0 of sine delta s over delta s is equivalent to 1, so that our dy delta y delta x become dy over the x. Here this becomes 1 over sine x times sine s, that will give us sine square x. Okay, sine square x. Please, we know this is minus here, this is minus, so it's going to give us minus. From here we have minus, so as we apply it to this become minus 1 over sine square x, and sine 1 over sine, the inverse of this is an inverse function, and 1 over sine is cosec, so that our dy dx of cot x become minus cosec square x, minus what? Cosec square x. So that is the derivative of this. So the y dx of cot s is usually minus cosec square x. Here we have used the method or the principle of first principle, to establish this. So we can also use the quotient rule to do this. But first principle also establishes this. Please, all you help me do is help me subscribe. Also hit the notification button so that when this comes up, you will get them. Have a nice time. See you in my next partial class.